Hello everyone, you're welcome to this video. This is a continuation of the video for Waec 2020. This is number 10 question. Now here we are asked to define critical angle. 10AI, define critical angle as used in optics. Okay, critical angle is simply an angle of incidence that gives a refracted angle of 90 degrees. So you can go ahead to draw this. When you have this and you have an incident angle this way, and the incident angle is equal to the critical angle if the refracted angle is 90 degrees. That's very, very important for you to note. Okay, so any angle that gives a refracted angle of 90 degrees is called the critical angle of that material. Very important. Now the next one says explain two conditions necessary for total internal reflection to occur. That's quite easy. The first condition is that light must pass from denser medium to less dense medium. Must pass from a denser medium to a less dense medium. Okay, then the second condition is that the angle of incidence must be greater than the critical angle. I'll just say I must be greater than C. That's the second condition. The angle of incidence must be greater than the critical angle. Very important, you know. The next one says list 3 practical applications of total internal reflection. They are very simple. Number 1 is mirage formation. Okay, so the way mirage is formed is that's total internal reflection. Another one is the fish underwater, C. Fish underwater, C by total internal reflection. That's very, 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 very important. Okay, so C underwater, C is by total internal reflection. Don't forget that. Okay, and there are many other things that uses it. Another one can be prism binoculars. Prism binoculars, right? Prism binoculars uses total internal reflection. And even prism projectors uses total internal reflection. Okay, so that's by the way. The other one says we should define progressive wave. Now, a progressive wave is simply a wave that is moving, that changes position. That's very simple. Or you can say a wave that transfers energy, or a disturbance that travels through a medium and transfers energy from one source to another. That's simply that. So the most important thing for you to note about waves is that number 1 is a disturbance. Then secondly, it transfers energy and momentum. Please don't forget that. That's the most important thing to remember about that. Now the next question here says a plane progressive wave is represented by the equation y equal to 0.5 sine 1000 pi t minus 100 pi over 17. Calculate the frequency of the wave, the wavelength of the wave, and the speed of the wave. Okay, that's very easy. Now you have y to be equal to 0.5, then sine, here is 1000 pi t, then we have minus 100 pi all over 17. Now in this case here, this equation, the real equation of motion actually looks like this: y equal to a sine, this will now be omega t, there's a mistake here, this should be 100 pi x. Okay, omega t minus kx. Okay, that's the formula. Or you can simply say a sine, instead of omega you can say 2 pi ft minus, instead of this you can say 2 pi x over lambda. K is 2 pi over lambda. It's called wave number. Now if you compare these two very well, we should be able to tell what we are looking for. For example, in terms of frequency, if you compare this and this, compare everything, you can see that amplitude is 0.5. Amplitude is the value attached to sine, so it's 0.5 here. Here you can see that 2 pi ft is 1000 pi t, so that means 2 pi f is equal to 1000 as t cancels out. So your frequency is going to be 1000 over 2 pi. You see that? That's easy. You can leave the answer that way, or you can substitute the value of pi, which is 3.142. Okay, now the next one is here. If you compare this with this, you can see that 2 pi over lambda is equal to 100 pi over 17. Can you see that? So from this we can find what it means, what that is. So we can simply say that okay, I think I'm trying to see. Okay, that's good. So if we cross multiply here, we're going to have lambda to be equal to 2 pi times 17 divided by 100 pi. This will cancel. 2 times 17 is 34. 34 divided by 100 is 0.34. So lambda, which is the wavelength, is 0.34. So if I want to find the velocity now is going to be frequency times lambda. The frequency is 100 over 1000 over 2 pi hertz. Then times lambda is 0.34. So if you like, we can just substitute the value for 2 pi, which is 2 times 3.142, then of course times 0.34, and that will give us the answer that we want. So if I say 1000 times 0.34 divided by 2 times 3.142, I get 54. So we have 54.111 meter per second. Okay, so that's the answer to that question. Okay, so thank you very much. See you in my next video for number 11.